Good morning, dear student. In today's lecture, we will start our semester second, in which we discuss the course that is CHI 432, in which we selected the A part, that is the material science. So, so in this CHI 432 material science course, there is a two sections, section 1 and section 2nd. So, in this lecture, we are very much interested in the section first, in which the chapter 3, that is superconducting material. So, we are very much familiar with this word, that is superconductors. So, we already know what is conductor, what is insulator, what is semiconductor. So what is this superconducting material, and what are the properties of the superconducting material, what are the different theories of superconducting material, we will discuss in this chapter. So let us discuss one by one. So before discussing what is superconducting material, so you should know the relationship between the resistivity and the conductivity, and what is the meaning of conductor. So we know that conductor, it is a material from which a current is flow. So the material from which the current is flowing is called conductor. So at least the first point is what the current is flowing from the material is called conductor. The material from which the current is flowing is called conductor. Again, every conductor has a property called resistance. So the second point is every conductor every conductor have a property have a property having a property that is resistivity or resistance. So the first point is what the material from which current is flowing is called conductor. Every conductor has a property that is resistance or resistivity. So what is this resistance or resistivity? That is tendency to oppose the current. Every material have a tendency to oppose a current flowing from that material is called resistivity. So tendency to oppose the flow of current tendency to oppose the flow of current is called resistivity. Resistivity. So at least you should know this. The material from which current is flowing is called conductor, but every conductor has having a property that is resistance. What is this resistance or resistivity? Tendency to oppose the current. Tendency to oppose the flow of current is called resistivity. Again, one more important point regarding to this resistivity, that the conductivity and resistivity are inversely proportional. So if you consider the conductivity, it is inversely proportional to the resistivity. Conductivity, it is inversely proportional to the resistivity. For example, if you consider sigma is your resistivity, sigma is your conductivity, then we can write sigma, it is inversely proportional to 1 by rho. So rho, it is the symbol for resistivity, and sigma is the symbol for conductivity. So from this equation we get a relationship, that is the conductivity and resistivity are inversely proportional. So sigma is inversely proportional to the resistivity, means as conductivity is increases, the resistivity is decreases. As the conductivity is increases, the resistivity is decreases. Okay, so this is the important point regarding to the superconductor. The material from which current is flowing is called conductor. Every conductor having a property, that is resistivity. Resistivity is nothing but tendency to oppose the flow of current. It's called resistivity. Conductivity is directly proportional. It is inversely proportional to the resistivity. Again, let us discuss some graphical representation for this. Before discussing, one more point is there, that is for conductor. For conductor, the resistivity R is not equal to 0. So in this case, for our convenient, the resistivity is denoted by symbol capital R. So for conductor, resistivity is not equal to 0, but for superconductor, the resistivity is equal to 0. The resistivity is equal to 0. So you should know, for conducting conductor material, the resistivity is not equal to 0, but for superconductor the resistivity is 0. Again, the relationship, that is conductivity is inversely proportional to the resistivity. Let us discuss some important graphical representation regarding to this conductors and superconductors, and then we discuss the definitions. So the important point is that the the resistivity, it is directly proportional to the temperature. So you should remember, the resistivity, it is directly proportional to the temperature. For example, if you consider a graph for uh, resistivity versus temperature, resistivity versus temperature for conductor, then we get such a kind of graph. So this is the graphical representation for the conductors. So this figure, it is for conductor. So what it indicate? The resistivity, it is directly proportional to the temperature. As temperature is decreases, the resistivity is also decreases. As temperature is increases, the resistivity is also increases. Okay, let us discuss the second graph for the superconductor. So then we resistivity and temperature. So we get such a kind of graph here. So there is a sudden drop in the resistivity. So this figure, it is for superconductor. Okay, resistivity is directly proportional to the temperature. So first figure, it is for conductor, and second figure is for superconductor. So we will discuss the difference between these conductors and superconductor, why the resistivity is falls suddenly. Okay, for superconducting materials. So this figure, this temperature, it is called critical temperature. Critical temperature. So above which the material it is conductor, and below which, if you consider the critical temperature, so above critical temperature the material it is normal conductor, but below critical temperature the material is superconductor. The material is superconductor. Okay, so this critical temperature denoted by symbol Tc. So this is the difference between the conductors and superconductors. So what is this critical temperature, what is this superconductivity? Let us discuss the definition, but at least you should know this all points. Conductors are the material from which current is flowing. Every conductor has a property called resistance or resistivity. The tendency to oppose the flow of current is called resistivity. The conductivity and resistivity are inversely proportional. For conductor, the resistivity is not equal to 0. For superconductor, the resistivity is equal to 0. The resistivity and temperatures are directly proportional. So as temperature is increases, the resistivity is also increases. As temperature is decreases, the resistivity is also decreases. But if you see the difference, as the temperature is decreases for superconductor, there is a sudden drop in the resistivity and it becomes 0 for superconducting material. So what is this critical temperature? The temperature at which a normal material turns into superconducting state is called critical temperature. So we already discussed that above this critical temperature the material it is normal conductor, but below this critical temperature the material is superconducting state. The material is superconducting state. So let us discuss the definition. That is the temperature at which the temperature at which the temperature at which a normal material turns or convert into the temperature at which normal materials convert into superconducting state. Superconducting state is called critical temperature. Is called critical temperature. Is called critical temperature. For example, the Tc for critical temperature for mercury, it is 4.2 Kelvin. 4.2 Kelvin. So what is this Tc or what is this critical temperature? The temperature at which normal material convert into superconducting material is called critical temperature. So the scientist Kamerlingh Onnes observed that. So this is very important. That is the scientist Kamerlingh Onnes observe this phenomena. Kamerlingh Onnes observe that for few material the electrical resistance drop to 0 below a certain temperature, and this material is called superconductor. So according to the Kamerlingh Onnes, few material for few material electrical resistance or resistivity drop to zero below a certain temperature. For few material the electric resistance drop to 0 below a certain temperature, below a certain temperature, and these materials are called superconductor. So if you see the graphical representation, the difference is seen. For normal conductor, as the temperature is decreases, when the temperature goes to 0 Kelvin, then the resistivity becomes 0 for conductor. But for superconductor, uh, at critical temperature, the material is converted into superconducting state. That is, we does not go we does not go for 0 degree Celsius. So there is no need to go up to 0 degree Celsius for converting the conductor into superconducting state. So above 0 degree Celsius, so below critical temperature. So critical temperature, we already discussed. The temperature at which normal material convert into superconducting state is called critical temperature. So the Tc for mercury is 4.2 Kelvin. So at 4.2 Kelvin, the mercury is converted into, below 4.2 Kelvin, the mercury is superconducting state, and above 4.2 Kelvin, the mercury is normal conducting state. So according to the Kamerlingh rules, so few materials whose electrical resistance drop suddenly at a certain temperature, and this material is called superconductor. The resistance of a superconductor in non-superconducting state is decreases with decreasing temperature. So you should remember, the resistance of a superconductor in non-superconducting state is decreases with decrease in temperature, because the resistivity is directly proportional to temperature. As temperature is decreases, the resistivity is also decreases. So the resistance of superconductor in non-superconducting state is decreases with decrease in temperature. This is similar to normal metal. At a particular temperature, the resistance is suddenly dropped to 0, and then onwards the metal passes into superconducting state. So at a particular temperature, that is the critical temperature, at a particular temperature, that is the critical temperature at which the resistance of a material is suddenly drop to 0, and then onwards the metal passes into the superconducting state. So this is the difference between normal conductors and superconductor. For superconductor, at a particular temperature, the resistivity is suddenly drop and goes into 0, and the material is converted from normal conductor to the superconducting state. So what is this superconductivity? If we see the definition of this superconductivity, the phenomenon in which the electrical resistance of a given specimen of metal or alloy fall suddenly to 0 on cooling to extremely low temperature is called superconductivity. So if we consider the definition of this superconductivity, what is definition of the superconductivity? The phenomenon in which, or the process, in which electrical resistance or resistivity electrical resistance or resistivity of a given metal or alloy falls suddenly. So we already discussed the graph of superconducting material. The resistivity or electrical resistance of a given metal or alloy fall suddenly to 0 on cooling, means on decreasing the temperature, fall suddenly to 0 on cooling it to extremely low temperature. So with a decreasing temperature, the electrical resistance falls suddenly to 0 on cooling is called superconductivity. So the process in which electrical resistance of a given metal or alloy falls suddenly to 0 on cooling at low temperature cooling at low temperature is called superconductivity. So at least you should know the difference between conductors and superconductors, the graphical representation for conductors and superconductor. In next lecture we will discuss the remaining points of this chapter, that is superconducting material. Thank you.